From the Library of Congress in Washington, D.C.
Well, good afternoon. My name is Jason Steinhauer. I'm a program specialist at the John W. Kluge Center at the Library of Congress. Today's lecture is presented by the John W. Kluge Center at the Library of Congress. The Kluge Center is a vibrant scholar center on Capitol Hill that brings together scholars and researchers from around the world to stimulate and energize one another, to distill wisdom from the library's rich resources, and to interact with policymakers and the public. The center offers opportunities for senior scholars, postdoctoral fellows, and PhD candidates to conduct research in the Library of Congress collections. We also offer free public lectures, conferences, symposia, and other programs, and we administer the Kluge Prize, which recognizes lifetime achievement in the study of humanity, and which we will award later this month. For more information about these and other events, as well as opportunities to conduct your own research here at the Library of Congress, please visit our website, loc.gov/Kluge, or sign up for our RSS list on the table on your way out. Today's lecture is titled Images of the Earth in American Children's Books. Our speaker is German Fellow Sibylle Machat. Machat's research focuses on the depiction of Earth in children's books from 1843 to the present. Her research draws on several collections held by the Library of Congress, including those of the Children's Literature Center, the Rare Book Collections, and the Grushnikov collection of Soviet-era children's books in the Business and Science Reading Room. Her study considers the collective imagination of space prior to photographic evidence, and through the imagery in children's books, clarifies the relationship of modern humanity to its planetary environment. More about Sibylle's work is currently on our blog, right up there, and she'll be telling you more about her research at the library during her talk. Sibylle Machat is an associate professor at the Europa University Flensburg and is currently a German fellow at the John W. Kluge Center at the Library of Congress. Her first book was titled In the Ruins of Civilizations, Narrative Structures, World Constructions, and Physical Realities in the Post-Apocalyptic Novel. At the Kluge Center, she is working on her second book on the depiction of planet Earth in American children's and young adult fiction. So please join me in welcoming Sibylle Machat.
All right, let's see. Can you all hear me okay like this? All right, so we're going to be looking at a lot of images in this presentation in the next 45 minutes. So if you cannot see one of the screens really well, now is your chance to move to a place where you can see it. It's more important to see the screens than to see me, even though, of course, it's nice that you're all looking at me, and a little scary too, to be honest. So first of all, maybe you've noticed these flyers that have been lying around. And if you haven't seen one already, please spend like 20 seconds thinking about how you would describe the planet Earth to a child. And just keep a couple of words in the back of your brain, and later on I'm going to ask you to compare whether or not any of these came up during my talk, like whether or not you've maybe been influenced, heard some of this before, or you came up with all new ideas. Okay, so before we start, I have a little Oscar speech to give. That's sort of what we jokingly call saying thank you to everyone that you need to thank up in the Kluge Center. A couple of people have said, oh, I need to write my Oscar speech, so I thought I would put the Oscar in there. So before we start, I want to thank the John W. Kluge Center and Mary Lou, Travis, Joanne, Lauren, Nancy, Jason, and Dan, and everyone else there who's been so great and supportive for what I've been doing here. I also want to thank my interns, Kira, who's already in Japan doing work there, and Katie, who's in the audience and who has been helping me with some scanning and other slightly boring things. Thank you. The Children's Literature Reading Room in Sibylle, who's also in the audience, has been very helpful. The people in the main reading room who have been letting me use their big scanner, they all know me by name by now, and so do the security guards. I always go there with my books and say, hey, I'm in the Kluge Center, I want to take these in and scan something and take them out, and by now they just see me and they wave. the Business and Science Reading Room, which is the place where you read the Russian children's book collection. So I've been there. The NASA HQ archives, Liz, Colin, and Jane, I spent 2 weeks there working with their material, looking for images of the Earth, early photographs to compare them to the children's books. And the Smithsonian Air and Space Museum archives, and Elizabeth's there, where I also went looking for early photographs. And last but not least, my home university, the Europa-Universität Flensburg, who told me, yes, of course you can go for 7 months and not teach in the summer term and do this. Without them saying that, I would not be here. Okay, so this is what we're going to be doing. The Earth in American children's books. We're going to start with a very vague picture of the Earth, which you can see there on the left next to the title and the little astronaut and the spaceship that's taking off. And then we're going to follow the path the spaceship is taking all the way until we get to the blue marble. So the first photograph of the whole illuminated globe of the Earth. Well, the half that you can see if you're taking a photograph taken by Apollo 17. Okay. So this talk takes place at a point in my project where I have spent a long time with primary resources, finding them, building a timeline and a database out of what I'm finding. But I haven't yet done very much work with secondary sources or critical thinking, really. I did that when I first got here. I thought, yay, okay, I'm going to analyze all these books in depth and look at what I'm finding and then really write it down. So I did that for a month. And then I looked at all the things I wanted to do and how fast my time was going. And then I changed my work process a little and focused more on the primary material itself. So this is in the way. What I'm going to show you in the next 40 minutes is still very much a work in process in all that it is. I'm showing you what I found, I'm letting you look into my archives, but I'm not claiming that my thoughts have been finished, if they ever can be finished at all. So our journey is going to take us through what triggered my project in the first place, one of the triggers, which I don't want to tell you too much about yet because it's going to spoil the moment. And then we're going to spend 5 short minutes on the theory behind analyzing children's books, so you have a little context for that before we're delving right into the thick of it. I'm going to be using 3 early children's and young adult books as the foundation for the pictures of the Earth that I'm going to be showing you and the picture that I'm going to be constructing for you, meaning that we shall return to these 3 books time and again. And then we will also look at how these things have changed over the interim 175 years. And these 3 books are going to be Samuel Goodrich's 1831 Peter Parley's Tales About the Sun, Moon, and Stars, J.L. Comstock's 1835 Youth's Book of Astronomy, and John Blake's 1836 First Book in Astronomy, adapted for the use in common schools. Thus, we're also going to preempt the 1843 from the poster by 12 years. But I found this book and I thought this is great and we're going to use this. And so we're starting 12 years earlier than advertised. I hope that's okay. But first of all, this is what really triggered my interest in this project. I'm going to be showing you a 2-minute video, and this is a compilation of the audio recorder tapes taken on Apollo 8, overlaid with the corresponding photographs that the astronauts were taking at the time the recording was made. The setting is, it's December 24th, 1968, sorry. 1868, we went to the moon 100 years earlier. Don't tell anyone. 1968. And Frank Borman, Jim Lovell, and Bill Anders have recently become the first men to leave Earth's orbit and thus to see the planet from a distance. Granted, orbit is also a distance, but this is a greater distance. And a little more recently, they've also become the first men to see the dark side of the moon with their own eyes and to orbit the moon. At this time, the time that the video is set, Apollo 8 has completed 3 full orbits of the moon, and the 3 astronauts are busy with their assigned tasks, prime among which is to extensively photograph the ground passing beneath the spacecraft and to visually appraise the approaches to 2 possible landing sites on the southern plains of Mare Tranquillitatis. And then the following happens.
Just prior to the subsolar point, on the south side and the floor of it, immediately there is one dark hole. But I couldn't get a quick enough look at it to see what it's like the agency volcanic. Oh, yeah, that's actually there. This is the first one. Wow.
I first listened to Apollo 8 audio recordings years and years ago when I was writing my PhD on an entirely different subject and needed some tangential information on the connections between famous photographs of the Earth from space and the environmental movement for a talk that I was giving at an interdisciplinary event. And what struck me about the recording was Bill Anders's choice of words. He does not say, look at the Earth, or look at that, or look at that side. No, what he says is, look at this picture. Implying something mediated, something framed, right? A photograph, a picture. It's not the Earth itself. He says, look at this picture. I might be overinterpreting this here, but it really struck me. And in a way, it's of course true. 99.9999999 and so on % of the human population will never see the Earth from space with their own eyes as a whole, but it's something that we always encounter in a mediated fashion, framed a certain way, labeled a certain way, an image composed and contextualized in a certain way. And even if you're an astronaut, one might argue you cannot see the Earth directly. You need at least one layer of glass between yourself and the Earth. Otherwise, you might see it, but it might be a painful and or short-lived experience, right? So it's always somehow mediated. So yes, look at this picture. That choice of words led me to thinking about pictures of the Earth and about the fact that photographs from space have now existed for 69 years, and thus, at the time of the Apollo 8 flight, had already existed for an incredible 22 years. So they've been around for a while, but they're also a pretty recent event in the course of human history, even if not entirely as recent as they used to be. If I look around here, I think that photographs have been around longer than any of us here have been alive, right? So it's been a while. Photographs of the Earth from space have been praised, among other things, as raising human consciousness to a new level of awareness of the Earth as a whole, of globality, of the environment. And while I certainly agree with the statement, in my opinion, thinking of the Earth as a planet is not as recent a thing as some critics and writers would make it out to be, and humankind has been imagining the Earth as a planet for a much, much longer time. So I went and became interested in and began looking for pre-spaceflight descriptions and images of the planet Earth, and now here we are. Over the last 6 months, I have, according to my bibliography software, looked at a total of 1,011 items from the Library of Congress, plus about 50 Russian children's books that I haven't been able to add to my bibliography yet because it doesn't deal with Cyrillic very well. Some of which were more relevant, some less, some which I've spent more time on, some of which I actually still have to look at in detail. I came here with a list of books that I knew that I wanted to see because I had seen images taken from them or read about them in other bibliographies, but I also tried to, as systematically as possible, go through the Library of Congress's digital and card catalogs to look for relevant books in my research area. Images of the Earth can be found in connection to a number of different fields of interest, of course, and the ones I spent most time on are books that are concerned with either astronomy, geography, space exploration, or spaceflight in general, and all the subcategories that fall into those. About 70% of my primary sources are fact books for children, whereas the other 30 are fictive space adventures of some sort. And though the lines often blurred, then most fact books for children include an imaginary part that's like, let's imagine we're astronauts going to orbit, going to the moon, going to Mars. So there's fiction in the fact books as well. I've also tried to build as complete a timeline as possible regarding which early photographs of the Earth were taken from various V2, Araby, Viking, and Nike Cajun rockets precisely when, and then released to the public precisely when, to compare and contrast them with the illustrations and descriptions which I'm finding, which was the reason why I went to the NASA archives, why I went to the Air and Space Museum, and also why I spent a lot of time down in the newspaper reading room looking at microfilm. And Kira, my intern, also spent a lot of time down there doing that. So that being said about the background of my project and my research, on to the images of the planet Earth. And children's book theory before that. In their book, How Picture Books Work, Maria Nikolayeva and Carol Scott assert that, and I quote, "The unique character of picture books is based on the combination of two levels of communication, the visual and the verbal." They continue on by stating that if we are making use of semiotic terminology, we can say that picture books communicate by means of two separate sets of signs, the iconic and the conventional. Iconic or representational signs are those in which the signifier and the signified are related by common qualities. That is, where the sign is a direct representation of the signified. A picture of a printer on a computer's command menu is an icon, a direct representation of the printer. In most cases, we do not need special knowledge to understand a simple icon. Conventional signs have no direct relationship with the object signified. The word print in a menu only conveys a meaning if we possess the code. That is, we must know what letters stand for, put letters together to produce words, and understand what the word stands for. Conventional signs are based on an agreement among the bearers of a particular language, both the spoken language and communications, such as gestures, dress code, and emblems. For anyone outside the given community, conventional signs do not carry any meaning, or at best, the meaning is ambivalent. To understand the word printer or drucker, or I'm going to mangle the Finnish, kirjoitin, you need to be fluent in the language in question, whereas the icon that symbolizes the printer transcends one specific language and should hopefully allow you to print things on computers where the language is set to one that you do not speak. And if you've ever accidentally changed the language of your operating system into one that you do not speak, you know just how long it takes to get back to something you're familiar with. So, yeah, the printer hopefully should work, even if it's set to Chinese. Both what Nikolayeva and Scott call conventional signs and iconic signs have existed in human culture for a long time and have not only given rise to two parallel types of communication, visual and verbal, but also have been frequently put into interaction with each other in such multimedia forms as, say, the theater, movies, TV shows, video games, comic books, and of course also picture books. Both the images and the words used in picture books are complex signs. The function of the words, the conventional signs, to stay with Nikolayeva and Scott's terminology, is to narrate, to retell, to report, whereas the images are there to describe, to represent, to illustrate, to visualize what has been narrated, to offer more or less concrete representation of the more or less abstract concept being narrated. And picture books exist somewhere between the two poles of word and picture interaction. On the one pole, you find text without pictures. And on the other pole, you find pictures without text. So somewhere in between, you find the picture book. Are there lots of pictures and very little words, or are there a lot of words and very few pictures? That's all a give and take. And even there, differentiations then need to be made between narrative and non-narrative interactions of the two extremes. So is it a story or is it a dictionary? Is it a picture narrative or is it a picture dictionary? Like A is for apple and B is for beer. Well, probably not in a children's book. According to Nikolayeva and Scott, images and text can interact in a number of different ways, from being symmetrical, where the pictures and the text tell two mutually redundant narratives, all the way via a number of steps to synleptic picture books, where two narratives are told independently of one another and can therefore also contradict each other. That theory, however, concerns itself with narrative picture books that tell fictional stories and does not focus so much on non-fictional narrative books, nor do any other scholars that I have so far found focus on those books. So most of these intricately interwoven narratives that Nikolayeva and Scott write about are not actually present in what I am finding, and a large amount of the books that I have been looking at are what they kind of lump together as plate books, meaning non-fiction illustrated books. I will show you that, notwithstanding the lack of theoretical, in-depth analysis so far. Depending on the time these books were published and the age of the intended reader, a variety in the interplay between the text and the illustration nevertheless takes place. One of my goals for my own book project is also to formulate a comprehensive theory of the interaction between images and text in non-fiction narrative children's books, based on existing scholarly work, of course. So that's one thing we're looking at. And the second thing that really interested me in my project and that I want to introduce you to for like the next 2 or 3 minutes is the interaction between metaphors and similes when talking about the planet Earth in children's books. So, Earth is like a ball or Earth is a ball? Those are the two things I'm finding. So a simile, Earth is like a ball, is a figure of speech that involves the comparison of one thing to another thing of a different kind, used to make a description that is then more emphatic or more vivid. A metaphor, Earth is a ball, is a figure of speech in which a word or phrase literally denoting one kind of object or idea is used in place of another to suggest a likeness or an analogy between them. While a simile compares two items, a metaphor directly equates them. In his book, The Philosophy of Rhetoric, I.A. Richards describes metaphors as, and this is another quotation, the supreme agent by which disparate and hitherto unconnected things are brought together. And he also calls metaphors a transaction between contexts. What a metaphor does is not just to compare, but to merge two distinct contexts together. As my talk is called Images of the Earth in American Children's Books, and not metaphors regarding the Earth in American children's books, we're going to be focusing more on visual representations rather than verbal ones and the interplay between the two. But in my final book project, I will definitely be looking at both, and we're going to touch on it a little bit here as well. So, while fantastic voyages into space have a long tradition, reaching back to ancient Greece and then continuing all the way to the present, from Lucian of Samos's True History from 160 after Christ to Johannes Kepler's Somnium from 1634 and Cyrano de Bergerac's A Voyage to the Moon in 1657, to name but a few. These are neither American books nor are they purposefully written for children, and there are no pictures of the Earth drawn in them either. So they exist, but they do not fall into my area of specific interest. However, the earliest book I found that is really of relevance is from 1831 and was written by Samuel Goodrich. So, Samuel Griswold Goodrich was born in August 1793 and died in May 1860. And he was an American bookseller and publisher, an editor and a writer, and among the first Americans who wrote and published books for American children and young adults. Previous children's books had not been written in the United States, but instead been imported from Britain and Europe, and for the most part, thus been written by British authors. Goodrich was responsible for the publications of dozens of works, ranging from pocket-sized chapbooks to massive geographies, and according to the Boston Globe, sold 6 million copies of his various books in total. And his most famous creation is the character of Peter Parley, and we're going to look at one of those books. Peter Parley in the books is a gouty old man who always tells children that if they bump into his foot, he'll stop telling them tales. He's like a bit cantankerous. And he tells children tales about botany, history, geography, astronomy, and various other subjects, thus teaching the fictive children in the books while entertaining them, and also the real children who are reading them are being taught and hopefully entertained at the same time. The book we're going to be looking at is one of the Peter Parley tales, and as you can see here, its title is Peter Parley Tells About the Sun, Moon, and Stars, and it was first published in 1831. The edition we are going to be looking at today is from 1836, and it is here in the Rare Books collection in the Library of Congress. The book is fascinating because it is an early example of both some features that will become common in children's books as the decades progress, and because it also, quite frankly, contains some rather strange illustrations, and also an illustration that points to a problem that will hound children's books illustrators for the next 125 years, which we'll get to a little later. But first, let's see what Goodrich actually has to say about the Earth in 1836. So I'm going to read the text for you, so just look at the picture. This is Chapter 4, Parley Tells About the Earth. On the following page is a picture of the world. I suppose you know that the world we live upon is a vast globe or ball, the outside of which is divided into land and water. You know that it is covered with seas and oceans and rivers and mountains and valleys and plains. You know that the earth is hung in the heavens with stars all around it. Goodrich continues on with facts and numbers about the earth, about the circumference and things like that for the next 2 pages, but interestingly quickly relativizes the size of the earth when he writes that, "How immensely large, then, is the earth we live upon? When we come to the foot of a mountain and look up and behold it, its magnitude fills us with awe and wonder, but the largest mountain is a mere speck compared with the vast globe. But large as the world is, many of the stars which glimmer in the heavens and appear to us small are much larger. Our world, when seen from these stars, does not appear bigger than they do to us. To the people who inhabit the stars, our Earth is a star. Look up at one of the stars in the sky and imagine yourself upon it. This world, dwindled by the distance, would appear to you a little glimmering light, so faint and far as to be scarcely visible. What is typical in Goodrich's explanation of the motion of the Earth and the other planets is that he tries to explain their motion by using everyday comparisons that are easily graspable by children, and that will, for a large part, remain unchanged all the way to the present day. When he talks, I quote, about the motions of the planets. I must now beg the particular attention of my little reader to what I am going to say. The 7 planets, of which I have been telling you, have each of them 2 motions. That is, they all turn round from west to east in the same manner as the Earth does, of which I told you a little while ago. They also move in vast circles around the sun. To make you understand this better, suppose you put a small stick through the center of an apple and call the stick its axis. Now turn the apple round on the stick. Very well. The apple turns round on its axis. In a similar manner, each of the planets and asteroids turns round on its axis. The Earth turns round on its axis every day or once in 24 hours. Some of the planets turn round in a shorter time than the Earth, and some of them in a longer time. Now suppose you take an apple and tie a string to the stem of it and whirl it about your head. We will call the circle, or path in which the apple flies about your head, its orbit. So, if you whirl it swiftly, the apple will go round in its orbit or go round your head 150 times in a minute. And this is what you can see here, right? There's the boy whirling the apple around his head. And this is what this looks like later on. Here are some more recent illustrations that show precisely the same concept, even if they, in more recent years, are usually applied to explaining how satellites stay in their orbits, thus putting the child holding the string in the position of the Earth, rather than that of the sun, which he or she inhabited in Goodrich's explanation. And these illustrations are from Rose Wyler and Gerald Amos's Golden Book of Astronomy, A Child's Introduction to the Wonders of Space, illustrated by John Paul Green from 1955, and Maurice Alwart's Timothy Space Book, illustrated by T.E. North from 1961. And if you look at the slides, I always give you the names of the authors, but also of the illustrator, because I thought we're talking about pictures, and then I need to tell you who actually drew the pictures. So this is the first one. So Rose Wyler and Gerald Amos's book. The boy here is the sun on the left-hand side of the screen for you. And the illustration on the right here, where the Earth is actually moving in its orbit and precisely parallels the boy whirling the stone around its head. It's a stone here. It's no longer an apple. And both of them explain the combination between centrifugal forces and gravitation, which keeps the Earth orbiting the sun. Maurice Alwart's book was published after satellites had been launched into Earth's orbit, and thus explains the interplay between centrifugal and gravitational force in terms of the Earth and its satellites instead. And the parallel is again made explicit by the 2 drawings on the right-hand side displaying significant parallel compositional aspects. The location of the boy's head parallels that of the Earth, right? They're in the same place in the picture. And the conker, this boy is not using an apple or a stone, but he has a conker. The conker is almost in the same place as the satellite is going around in the orbit. So again, you can see the parallel compositions between the 2 pictures. So, one parallel. But back to Peter Parley for now. The next 2 illustrations show how Goodrich explains that the Earth turns around the sun rather than the other way around, and that the sun always shines on some part of the Earth. So on the one on the left, you can see someone reaching out behind a curtain holding an apple. So that's an apple on a string that he's holding next to the candle. And the other one has the sun shining on the Earth. So if you turn the apple that you have on the little string, the candle shines on its other side. And while your side might turn dark, the candle keeps shining on the apple all the same. This illustration also introduces one of the problems that children's book illustrators often contended with, and especially in more recent, no, not so recent books, where to put the clouds. Where do you put the clouds, right? When you look up at the sky, you see clouds. But when you look at the Earth from space, do you see clouds or do you not see the clouds? And if we've talked about my project at any length in time, I've probably joked to you that before 1946, the weather on the Earth was much better because there are never any clouds. There are never any clouds from space, very rarely. Interestingly, this is not quite true for this Peter Parley illustration. Here the artist clearly knew that he had to include the clouds somewhere. But at the same time, if you don't want to obscure the view of the Earth and paint them on the Earth, and then the people can recognize the Earth, where do you put them? So here, his solution was to put them around the sun, which technically, from the point of view of someone standing on the Earth and looking up, is kind of true, but also, of course, not actually the case. So keep in mind where the clouds are. And last but not least, there's also this interesting view of the Earth in the book, which really seems to be planet water rather than planet Earth. So we're going to zoom in a little. The quality of my image is not the best, but you can see this is water world more than it is anything else. The book does not give any explanation for this. It just has a ton of ships on this planet and no continents, which is interesting. And another interesting image I'm going to show you is from Samuel Goodrich's 1846 National Geography for Schools. And there, so this is the front page. And there, again, we see the clouds around the Earth, and the Earth looks like this. Is there anything that might be missing? Asia, yes. So here, the visible part of the Earth is only North and South America, nothing else. But he included the clouds, so something of this and a little less of that. So now you've seen Goodrich's problem of where to locate the clouds, and also some images of the Earth without any clouds actually between you and viewing it. Let me show you how the planet Earth and clouds on the Earth's surface are depicted in the intervening 180 years. So these three, I hope you can see these okay even from the back. These are from John Astor. Yes, the John Astor's, A Journey in Other Worlds, A Romance of the Future from 1894. Mary Proctor's The Children's Book of the Heavens from 1928, and The Stars for Sam by W.M. Reed from 1931. And here you can actually see some clouds. If you look at the Astor picture, which is the big one, the description says the signals from the Arctic Circle, so they need to find out where they're going to land, and the signal helps them with that. But you can actually see South America and some clouds around it, whereas in the other two books, Proctor still has some, but then in W.M. Reed's book, it's the first book where we're starting to lose the clouds. So we have clouds, and then we start kind of losing the clouds. And we will not see any clouds for a while. So these are the next illustrations. These are from between 1935 and 1945, and that's when we really start seeing lots of books about space exploration again. In the decades before that, they are few and far between. They're either in fiction or they're astronomy books. And it took me 2 weeks to figure out why that is. Why do people talk about space a lot, like in the 1840s, 50s, 60s, 70s, and then they stop? It's because people start building planes. And all the boys' books of wonder are about aviation and not about the stars anymore. I felt very stupid once I'd figured that out. And I thought, of course, that's when we start having aircraft, and everyone's about, hey, we're going to fly to the pole, and not we're going to fly to space. But space comes back. So here, as I said, these are from W.B. White, Seeing Stars, 1935. Arthur Draper's Wonders of the Heavens from 1940. Bertha M. Parker, The Earth's Nearest Neighbor, which is the big picture, and then the picture book of astronomy by Jerome S. Meyer, which we will keep coming back to today, which is the bottom left picture. And here, what is significant is that the Earth pretty much looks like a globe from space. So there's an absence of the clouds. We see very clearly North and South America, and in American children's books, it's always North and South America that you see. In Russian children's books, it's not Russia. Interestingly enough, they often show like the North Pole or parts of Europe. They don't focus to such a degree on the US and South America as American children's books do. So now we're 1945. There are no clouds on the planet Earth. Everything is sunny everywhere. The weather's always good. And then science has to come in and ruin the view. So it's 1946 and this happens. This is the first photograph of the Earth on which you see clouds from above. And it was taken on October 24th, 1946. And it's the first photograph from space. It was taken from a V-2 rocket launched in the New Mexico desert, which had been fitted with a 35mm motion picture camera and went up to a suborbital altitude of 105 kilometers, or 65 miles, as I should probably say here. The camera was destroyed after being dropped back to the Earth, but the film survived. You can see it here at the top left, along with an image of the page from the Christian Science Monitor, which talks about it, which is on the right. And here, courtesy of the microfilm collection in the newspaper reading room. I'm showing you this page here alongside the photograph so you can get a feeling for the fact that these images were widely circulated in the press, which indeed they were. And another highly influential publication, this time not a photograph, but a magazine article, or rather a series of magazine articles, and was published in Collier's between 1952 and 1954. And that's this one. And these are some of the most influential drawings of the planet Earth ever, 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 and especially of space stations. They inspired a great deal of children's books illustrators. Collier's ran a series of articles on humankind's future in space, in which leading scientists talk about space exploration. And these illustrations here were taken from the first of these issues of Collier's, and this one was called Man Will Conquer Space Soon. The art was drawn by Chesley Bonestell, one of the pioneers of space art who greatly helped popularize space travel and whose illustrations have become so iconic that people refer to other artists as either being Bonestellian or not quite Bonestellian enough. Here he is illustrating an article written by Wernher von Braun about space stations and crossing the last frontier into space. And if you keep this picture in mind and then look at the next ones, you can see what I mean about them being very influential. So, especially the two on the right, they seem almost identical, right? It's a different artist, but he clearly copies the style. These are from Arthur C. Clarke's The Exploration of the Moon, 1954, illustrated by Ralph Smith, and then Rose Wyler and Gerald Amos's Golden Book of Astronomy, A Child's Introduction to the Wonders of Space, and Willy Lay's Man-Made Satellites, Adventure in Space from 1955 and 57. And both of these were illustrated by John Paul Green. So that's why the images look so similar. It's the same artist who clearly was influenced by Chesley Bonestell. The Earth looks a bit scary here. There's not a hole being dug in the Earth, or the Earth is not slowly disintegrating into itself. The book is illustrating an eclipse of the moon, what that would look like from space. So the moon's shadow is on the Earth here. That's why it has that dark spot. The next photograph that is very influential, the next photograph is from 1959 and shows the first photograph of the Earth taken from a satellite, namely by the Explorer 6 satellite on the 14th of August 1959 from a height of about 27,000 kilometers or 17,000 miles. It shows, that's the one on the top left, it clearly shows a sunlighted area of the central Pacific Ocean and its cloud cover, right? Of much better quality was the first television picture from space, sent to Earth on April 1st, 1960, and taken by TIRAS-1, the first successful low-Earth orbital weather satellite, and the first of a series of television infrared observation satellites, which is the picture at the bottom left. It shows the coast of Maine and Canada's maritime provinces, and this is when you really start seeing the curvature of the Earth and to a greater degree and cloud cover of the Earth, and you start actually using television pictures to talk about the weather. And suddenly people know what clouds look like from space to a far greater degree than they did before, even there, though there they already know it for a little as well. And next then, and this is what really, really kicks it all off, it's time for humans to get in on the photography action. Yuri Gagarin became the first man in space on April 12, 1961. And in February 1962, John Glenn, the third American in space, took his camera along with him and brought back, among others, the photograph of the Earth that you see on the right-hand side. And this is when you start having pictures taken by humans from space who then can talk about what they saw, what it felt like to be in space. And that adds an entire different dimension to the way that people draw the Earth and talk about the Earth in children's books. And again, here are 4 illustrations that sort of parallel this cloud cover. Some of them are more realistic and some less, but there are also some time in between. So the one where it's still very sunny, except for this tiny piece of clouds out in the Pacific Ocean, close to Mexico, is from 1958. And then the one on the right where the clouds are sort of forming a little band around the Earth. I loved that image when I saw it. It's from the Sun, the Moon, and the Stars in 1959. And then the bottom 2 ones are, the bottom right one is from 1961, and the one on the bottom left is from 1963. And that one talks about the first astronauts in space while showing the Earth with a big cloud cover. So again, in the bottom right, you can clearly see there are more and more clouds being drawn around the Earth as we have the photographs. So I'm going to skip back here. Look at the top right photograph and then compare it to the bottom right picture. Right. So, but maybe the most influential single series of photographs for children's books is actually of a spacewalk. So the photograph on the top left here shows Ed White's spacewalk on the Gemini 4 mission in June 1965. And this is copied widely in children's books. So either they use the photographs themselves, as in the top right, The World of Rockets by Alexander Grosby, or in the bottom 2 pictures where the photograph inspires art. Before that, the depiction of astronauts is kind of all over the place. People don't quite know what the spacesuits are going to look like. They have huge antennas sticking out of their head. You're going to see one of those pictures later. But after this, spacewalks look like Ed White's spacewalk. So the next important image is from November 10th, 1967, and offers the first full view of the planet Earth that the public actually gets to see. There is most likely, arguably, an earlier photograph taken by a military Dodge satellite, which was never released to the public. And so while interesting, is not interesting to my project, because if it's never released, it cannot inspire anyone, right? And like the photo that I will talk about after this one, this photograph has been largely overshadowed in collective memory since, in its case, by Apollo 17's famous blue marble photograph. So if I ask you what was the first photograph of the completely illuminated globe from space, most people will say the blue marble. It wasn't actually, it was this one, which was taken 5 years earlier than the blue marble. But when this photograph here was taken, it was a huge deal at the time in children's books, and it was very quickly adapted into them. So it was released, it caused huge excitement for the public, and it was very quickly covered and put into children's books. So at the top right, this book is called Exploring and Understanding Our Solar System by Daniel Q. Posen. It's from 1968, so the year after, and they copy the image. They also reverse it for some reason, so everything is the wrong way around, but it's the first color photo of Earth taken from space by the ATS-3 satellite. And then in the books at the bottom, here they go chronologically, actually a little all over the place. So the one with the Wheelie space station is from 1971, and then at the far left it's 1977, bottom 79, and then 2008 at the right, which I show you here to see that today it's mostly photographs of the Earth that are used in children's books. They don't do illustrations so much anymore, they use photographs because we have so many great photographs. So photography-wise, it is 1967 now, and that's the year before Apollo 8 goes to the moon. And that is where we will leave space photography for now, for the relationship between the Earth and the moon is something that is also extensively covered in children's books as well, and for which we shall once again start in the 1840s and then move our way forward. All right. There are 2 more books from the 1840s that I want to delve into a little, namely J.L. Comstock's Youth's Book of Astronomy from 1835 and John Loris Blake's first book in astronomy adapted for the use of common schools from 1936. They are both interesting because they, while not providing the reader with any detailed illustrations of the Earth itself, discuss what the Earth would look like when seen from the moon, and thus highlight a very common feature of children's books. Someone is standing on the moon and looking back at the Earth. And when I say it's a very common feature, I mean it's a very, 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 very common feature. It's almost in every children's books where you go into space, you stand on the moon and you look back on the Earth and you think something about the Earth. and that changes over time. So Blake, do I get this? So Blake, in his first book in astronomy, adapted for the use of common schools, writes the following. As the moon illuminates the Earth by light reflected from the sun, so it is reciprocally illuminated by the Earth, which reflects the sun's rays to the surface of the moon. And as the surface of the Earth is more than 13 times greater than that of the moon, the Earth must appear to the inhabitants of the moon 13 times larger than the moon does to us. The rotation of the moon on its axis being performed in the same time that it goes round the Earth, it is plain that the inhabitants of one half of the lunar world are totally deprived of the sight of the Earth unless they travel to the opposite hemisphere. So if you live on the moon, it depends on where you live, whether or not you get to see the Earth. If you live on the far side of the moon and then you go around the Earth, you go, oh, what is this thing, right? And Comstock kind of writes the same thing, but he does so in a far more lyrical fashion, which is why I'm quoting it too. We have already stated that one side of the moon is never turned towards the Earth. Consequently, to the lunarians, which are his inhabitants of the moon, who live on the side nearest to us, the Earth is always visible, except when the moon is in opposition. But those who live on the opposite side of the moon and always stay at home never see the Earth at all, because that side is never turned towards us. A lunar astronomer who happens to live on the side directly opposite to us would have to travel a quarter of the circumference of his planet to see the Earth at all. That is about 1,500 miles. And if he would see our orb in its greatest magnificence, he must go 3,000 miles, or to the middle of the part next to us, where indeed he would behold a spectacle which any terrestrial astronomer would be happy to enjoy at such an expense. Namely, a moon always directly over his head, 13 times as large as the full moon appears to us, and turning on its axis, so that he could examine every part of it in 24 hours. Don't you want to live on the moon now? Yeah. So, as I said, unfortunately, no detailed illustrations of the Earth from space, or indeed what the Earth might look like from the moon, are provided by either Blake or Comstock. The most you get is in Comstock this drawing of an eclipse, like when the moon is dark, but because the Earth is between the sun and the moon. That's the most you get of the Earth. And it takes almost 100 years until the first image of the Earth as seen from the moon shows up in children's books. And it is in 1924 in Mary Proctor's The Children's Book of the Heavens. And it looks like this. This is a typical image for the 1920s. So it takes a while to show up, and then these are the kind of images you get. And the best one in color that I have found, which is why I'm showing it to you here. The moon, as we all know from seeing it at night, shines bright yellow in the Earth's sky. And so for a long time, it seemed to follow that the Earth too would be bright yellow when we looked at it from the moon, right? One is yellow, the other one is yellow. Seems logical. This one is actually a slightly atypical in that it does not show some detail on the Earth's surface, even if the planet as a whole seems more reminiscent of drawings of Mars and the canals that might exist on Mars that were also frequent subjects in children's astronomy books of the time, right? If I said to you, what is this? You'd say, oh, is this Mars? It's the Earth. And the description says the Earth seen from the moon's Apennines. So, details start showing up in the 1930s. And these three images are from left to right, from Elena Fontani's Other Worlds Than This, from 1930. Otto Gale's By Rocket to the Moon, the story of Hans Hart's Miraculous Flight, from 1931, and W.M. Reed's The Stars for Sam, 1931, as well. So, interestingly, the continents here are only vaguely determinable, and clouds do seem to actually exist and obscure the features of the Earth. So again, it's a parallel to the earlier pictures we had of the Earth. In the 1930s, you have clouds. In the 1940s, there are no clouds. And maybe unsurprisingly, if you look at the Earth from the moon in the 1940s, there are no clouds. So we're going back to Bertha M. Parker, The Earth's Nearest Neighbor, and then Jerome S. Meyer's The Picture Book of Astronomy, and on the far right, Marion Cothran's 1946, This is the Moon. Which sort of has the Earth rising behind the moon. And this way of drawing the Earth doesn't really change until the late 1950s, when clouds start appearing in these drawings of the Earth as seen from the moon. So it really takes us after the first satellites are in space, but before manned spaceflight begins, for these pictures of the Earth to change a little as they are seen from the moon. And then you get pictures like these. All four of these are primarily concerned with our future in space and exploring the moon. So you can see various iterations of rocket ships going there, or unmanned probes that might land on the moon. But you also always see the Earth somewhere in the lunar sky. That's very common. If you draw people landing on the moon and working on the moon, you always include the Earth somewhere to show that they are on the moon and not on some random planet, and because it's a nice visual sight. So, where am I? I ad-libbed. Photographs of the Earth as seen from lunar orbit are something that, once they are available, are also quickly integrated into children's books as well, somewhat unsurprisingly probably. Maybe even more so by sheer amount than the early photographs of the Earth from orbit actually are, which often only inspired art itself rather than being copied one-on-one. The first photograph of the Earth from lunar orbit, which was taken in 1966 by the Lunar Orbiter, thus very quickly turns up in front papers and end papers of children's books, as well as integrated into the text itself. Today, again, few people might recall that this image existed, as it has been overshadowed by the Apollo 8 Earthrise photograph, which you saw earlier, but it did exist. And interesting about this picture is that while it is integrated into the text sometimes, it also shows up in the front and in the end papers, even if the book doesn't really talk about it. It's just there because it exists and you want to show it to the children. It's my theory. It's like it doesn't really fit in the text. Maybe the text was written if the book is published shortly after, but you do include this picture. And of course you can show it in the full spread, which is very nice visually. So these here are two books from 1967, which use them in the front paper, and then in David Dietz's Stars and the Universe, it's actually in the text when they write about the moon, what the moon might look like. So they use pictures that were taken on the surface of the moon, and then also one from orbit. But there are two pictures that I really would like to talk about in more detail right now, rather than showing you endless repetitions of globe Earth and spiky moon terrain. They're always such spiky mountains. And these are both from a book that was written and illustrated by Anthony Ravielli, and which is called The World is Round. The World is Round spends most of its time explaining that the world is round, even if you can't see that the world is round. So he says the Earth is a ball, and the Earth is a really big ball, but imagine you're a tiny fly sitting on this really big ball. So to you it seems flat, but if you're a child holding this big ball, it's nevertheless round, even though the fly can't see it. So like 80% of this book is actually about explaining why the Earth is a ball, which here the title already shows you. And then it talks about the Earth as a planet and space exploration and the space program a little. And what is interesting about this book is that the Library of Congress in its general collection has two editions of this book. And they're identical to each other, except for 2 pages, one 2-page spread, namely pages 46 and 47. And this is what they look like. Does anyone want to hazard a guess what might have happened between the first and the second edition of this book? Or when they might be from, very roughly. What has happened here? The moon landing has happened indeed. The book on the left, it's the, let's see if this works, yep, it's the 1963 edition of the book. And the one on the right is the 1970 edition of the book. And so you see a couple of interesting changes. And if you look at the 1963 one, so the one on the left, the moon still has the very spiky mountains that everyone thought the moon would have. There's no atmosphere on the moon, so there's no wind, there's no water, so there's nothing to corrode the mountains away, hence the mountains must be very spiky. The stars are very clearly visible in the sky. The moon lander looks somewhat different. People are climbing out the top, which leads you to the question, how do they possibly get out of that thing to the lunar surface if they're climbing out the top? And then the Earth looks very different from the moon, right? There are very few clouds. It's very clearly the two Americas are visible. And then on the right, the moon landing has taken place, so you have a realistic depiction of the lunar lander, of what the gear you need to wear on the moon looks like. The stars aren't as visible anymore, and the Earth is very, very cloudy, as it looks like from the moon, indeed. And this book was both written and illustrated by Anthony Ravielli, so clearly he cared enough about the inaccuracies of his book that he said, I'm going to draw a new page 46, 47, and we're going to include this in the second edition. And I brought both versions of the book with me. I brought some books with me you can look at after the talk and the Q&A if you want, and so you can sort of compare and see that indeed everything else is the same. What does the moon actually look like? What does the Earth look like from the moon that you can see in this picture? So this is a photograph taken by Gene Cernan on Apollo 17, and it shows you what the Earth actually looks like in the lunar sky. It's kind of tiny and unimpressive, isn't it? So it's very hard to photograph. If you've ever tried photographing the moon, you've had this problem. Either you zoom in so you see nothing else except the moon, or you take a picture and then there's this tiny moon somewhere. And the same is true of the Earth. So here you see the boulder in the foreground, and then the half-lit Earth in the sky. In drawings, in children's books, the Earth is much bigger and more impressive. So you could see that in the Ravielli book, where he didn't change the size of the Earth. He kept that pretty much the same. He just changed what it looks like. And you can see it in these here. And the top right book is one that I actually think is a little creepy. It's called The Happy Moon. It's from 1972, and it's about the fact that the moon is really, really very happy about having people land on it. But to me, it looks like you're kind of stepping on the moon's face. So I read that book and I thought, oh, actually, this moon makes me feel a little creeped out. And then at the bottom right is just one of my favorite illustrations because it's such a nice spread. It includes the text and the imagery really well. It shows you the lunar surface and the astronauts and the Earth and the sky. This is by Richard Whittingham and Barbara Brooks's The Earth and the Stars. Unfortunately, it doesn't tell you who drew the picture. And the one on the left is from 1969. So it appeared late in 1969 after the moon landing. It's called We Came in Peace, The Story of Man in Space. And it's one of the first picture books to deal with the moon landing itself. And ever since the moon landing and these pictures appeared, this is what illustrations of the Earth from the moon have looked like. The moon is flat, there are no spiky mountains. The spacecraft look Apollo-like, the Earth is cloudy. And due to time constraints, because I think I'm kind of getting on with my time, I see Jason nodding in the back, this is where we're going to stop looking at Earths from moons and instead turn our attention very briefly to images that illustrate more abstract ideas and that thus closely tie into the analysis of the use of metaphors and similes in children's books, which I want to at least introduce you to a little. And this is also the point where we get to the merry-go-round that you maybe saw on the poster for my talk. So the first thing I want to talk about is actually more about the solar system than Earth itself, and this is how do you explain gravitational forces to children, right? We had the one where the Earth flies around on that string, but if you want to talk about the solar system, what I commonly find are tugs of war. So tug of war is a way of explaining to children that all the planets influence each other. So the one on the left is from Elena Fontany. Again, we're coming back to her Other Worlds Than This from 1930. And the one on the right is from Herbert Townsend's A Wonderful Earth, the story of how it became the great round Earth it is today. And so here you actually, in the Townsend, you see on the right-hand side, you see the sun sort of having a tug of war with all the planets. So all the planets against the sun, and the sun is probably still going to win. And then on the left, which is the same as in Fontany, except that in Fontany you have people pulling, it's like some of the bigger planets, or certainly the sun, have more influence, and the smaller ones have less, so they're drawn as smaller people, but it also depends on where you are in the solar system. So Fontany's description says, the man with the greatest pulling power is not always the biggest, nor always the nearest. So Uranus might have more power on Neptune than the sun because the sun is farther away, her illustration seems to say. And the second one is merry-go-rounds, so many merry-go-rounds. So again, this is a way of explaining the fact that the Earth turns around itself and also rotates around the sun. So in Jerome and Meyer's book, which is also the poster that I have, you can see the merry-go-round superimposed on the Earth and the stars, and it explains the fact that the Earth turns around itself like a merry-go-round. And the other three illustrations are actually somewhat more interesting, especially the two on the right-hand side. So on the top one, in Hermann and Nina Schneider's You Among the Stars, illustrated by Simeon Sherman, the page before explains actually that the Earth is like going to the dentist, which is a painful thing, isn't it? But you go to the dentist and you sit in the dentist's chair and you take your brother and your brother spins you around in the dentist's chair, right? So that is the Earth spinning around itself. And now imagine we're putting this dentist's chair on a merry-go-round. So the center of the merry-go-round is the sun, around which all the horses turn, and then your brother turning you in the dentist's chair is the Earth turning around itself. And at the bottom right, you have Julius Schwarz's The Earth Is Your Spaceship from 1963. So this is also interesting because it is an early mention of the Earth being a spaceship, where they put the merry-go-round on a truck, and the truck drives in a circle. Okay, so here the Earth is the merry-go-round, and the truck driving in the circle is the path it takes around the sun. And last but not least, on the bottom left, Gerald, Amos, and Rose Wyler, again, they wrote a lot of books about the Earth. This is called Planet Earth, this book, illustrated by Cornelius de Witt. And there you have the Earth turning around itself with people standing on it. So the Earth is the green planet, and on top of it is the merry-go-round. So rather than superimposing it, they attached it at the top. So you can see both the planet turning, you can explain that down is always towards the center of the Earth, and that the Earth is turning around itself like a merry-go-round. So if you remember back to what you thought about the Earth and how you might explain the Earth as a planet to a child, did you find any parallels? Did you find any differences? Did you think of a ball? Did you think of a merry-go-round? Did you think of a dentist's chair, maybe? If you have any thoughts you want to share about that, I would be very happy to hear them, maybe after the Q&A. And so far, the only thing that remains for me to say, is thank you. There we go. And that we have now arrived on the planet Earth, and you can see all my sources where the illustrations came from. Thank you. And if you have any questions, feel free to ask them. Is there?
We have about 5 minutes of tape left, so we'll do 5 minutes of Q&A, and then after that, I think Sibylle will stick around to answer additional questions.
Sure.
You mentioned, this was so interesting, you mentioned about how there was a comparison with Russian children's books. Can you talk more about how the American depictions of the Earth different from or similar to children's books in other parts of the world?
Okay. I can say something about this, but this might not be my final answer. So something I want to actually do for my project, I'm learning Russian right now, and I want to go to Moscow to look at the Children's Book Archive. And after that, I will have a much bigger answer. But from what I've seen so far, is the art style is, of course, very different. Clouds show up at around the same time, so we have a strange parallel in the presence and absence of clouds. But again, we have a focus that is far less on Russia, which is something I found really, really interesting. And at first I thought, is Russia maybe too big to fit on the Earth? But it's not true. If you look at the globe, you can actually see all of Russia. And what they frequently focus on is either the North Pole, so looking at the Earth kind of from above, but tilted a little more towards Russia than straight north. Or they show the western part and Europe, and then the western part of Russia. That's what I've found so far. The text, I have a friend in Germany who helped me translate some things because he's a translator. And the text I haven't really looked at yet because my Russian isn't good enough yet. But I hope to come back to you with an answer, because I thought if I'm looking at American books, wouldn't it be super interesting to look at both space powers and do that? And I've looked at some German books, I've looked at some British books, but if I look at those, then you can just say, aren't you being arbitrary? Why aren't you looking at French books and Spanish books and Chinese books? So I said, no, there's 2 space powers is what I really want to write about. So my project has kind of grown. Yeah.
It appeared that there is suddenly abundance of books in the 1930s. What would account for that?
I think, from what I found, it's really only the 40s. I showed you the examples I found in the 30s, but these are actually some of the only books I found in the 30s, whereas in the 40s and 50s I really had to choose. And I think the sort of what accounts for it is, for the lack of books on the one hand, is that there are so many books about airplanes. So if you want to write books for, adventure books for boys, they're all about aviation. I've looked at so many aviation books which then have modern planes, the new planes that will be invented, adventures in planes, going to the North Pole in planes, going here in planes, famous people who flew planes. Really, there are so many of those. But then I think with the development of technology and with the first rockets being invented by the Germans during the Second World War, and these then coming to the States, that's sort of when people realize it might become realistic that we can go into space. And that's when you really see these books taking off. And certainly after 1952, 53, 54, that's where most of my books really start, which is actually kind of late for me. I wanted the ones from before we have photographs of the Earth, before we have the pictures of the clouds, but there aren't that many. It's after we have the first photographs and the V2s go into space and take these pictures, and people start writing about White Sands and Wernher von Braun and Huntsville and all of that. And then Cape Canaveral / Cape Kennedy later, that's when the books really, really start appearing.
You mentioned that American picture books started around the 1830s, and until then they would often have picture books that came from elsewhere. Did those British picture books from the time before the 1830s depict the Earth, and it's American children would see them, and how would that influence children and how the American picture books started?
That is a very, very good question. Of the picture books that I have found here, there hasn't been any Earth, but negative evidence is not complete evidence. So to be able to say, I really can't find any Earth in the British children's books, I need to go to the British Library and look at the early British children's books. And then all I can say is that in the books that are here, there is no picture of the Earth. But on the one hand, I focused on American children's books, so I didn't spend a lot of time with the British children's books. I'm more in, this is kind of interesting. I wonder what's in them, as I found out when the first pictures of the Earth started appearing. And yeah, as I said, it's just me saying that there's at least one swan in England which is white on one side, rather than saying all swans in England are white. Okay?
I think we'll stop there. Please join me in thanking Sibylle. So I think Sibylle will stick around for a few more minutes. She has a few books that she has brought in for people to look at, and she can answer a few more questions. The Kluge Center is on break with our programming until October, at which point we have a number of lectures coming up, so please do sign our list on the way out, and thank you again for coming.
This has been a presentation of the Library of Congress. Visit us at loc.gov.